But to find the basis for the column space, what we have to do? We are taking column vector which have leading entry in U in row echelon matrix, and corresponding that column vectors consider corresponding column vector from A, and that column vectors are basis for the column space. Okay, so just try to keep in mind using the previous theorems. So first target is we convert this matrix into a row echelon form. Okay, so here is the first process. We multiply first row. You can see from the matrix we multiply first row with -2 and add into the second row and third row. We multiply first row with 1 and add into the fourth row. So here is the process. First process, you can see and check. First row is 1 4 5 4, second row is 0 1 -2 -6, third row is 0 1 -1 -1 and 0 0 0 0, last row. We multiply second row with -1 and add into the third row. 1 4 5 4, first row is as it is, second row is also as it is, because we multiply second row and add into the third row. So whatever the changes become in the third row. So 0 0 1 5 is the third row and 0 0 0 0, which is in row echelon form. Now in this row echelon matrix, you can see in this row echelon matrix, you can see on the screen there are 3 rows which have leading entry. There are 3 rows which have leading entry. First row have a leading entry 1, second row have a leading entry 1, third row have a leading entry 1. So that 3 row vectors 1 4 5 4, 0 1 -2 -6 and 0 0 1 5, that 3 row vectors form a basis for the row space of A as well as U. Okay, so 1 4 5 4, 0 1 -2 -6, 0 0 1 5 are basis vector for a row space of A. So here is the answer using the above theorem. R1 R2 and R3, the first 3 row vectors of U form a basis for the row space of A. And now which 3 column vector have a leading entry? First 3 column, you can see first column have a leading entry 1, second column have a leading entry 1 and third column have a leading entry 1. So first 3 column vector have a leading entry 1. So that 3 column vector form a basis for the column space of U. First of all U. So call it C1 dash, C2 dash and C3 dash. These 3 first column vector 1 0 0 0, 4 1 0 0 and 5 -2 1 0. You can see from this matrix 1 0 0 0 first column, second column is 4 1 0 0, third column is 5 -2 1 0. These 3 column vectors form a basis for the column space of U. Okay, but we want to find the basis for the column space of A. So what we have to do here? In U, in row echelon matrix, first 3 column vector form a basis for the column space of U. So consider corresponding column vector of A. Consider corresponding column vector of A. So we have to take first 3 column vectors of A, and that 3 column vector form a basis for the column space of matrix A. So consider first 3 column vector 1 2 2 -1, 4 9 9 -4, 5 8 9 -5 from A. So that 3 column vector, you can see C1 1 2 2 -1, C2 4 9 9 -4, C3 5 8 9 -5 form a basis for column space of A. So here is our complete the example. Very important example. Okay, so in every time this type of example ask in GTU. Let's see one more example. Find the basis for the column space and row space of A. Same process, nothing change. We convert into a row echelon form. We multiply first row with 1/2 and add into the second row. and we multiply first row with minus 5 and add into the third row. So below the 2, minus 1 becomes 0 and 10 becomes 0. So first row is as it is, 2 minus 4, 1, 2 minus 2 minus 3. Second row is 0, 0, 1 by 2, 1, 0 minus 5 by 2. And the third row is 0, 16 minus 7 minus 6, 8, 19. Okay, you can check with very easy process, nothing difficult. Now we are interchanging second and third row, and then we multiply third row with 2. Okay, so the leading entry become 1, nothing. So this is the row echelon form, you can see on the screen and try to check, very easy process. Now 3 of the row vector, you can see in U all the 3 rows have a leading entry. 2 minus 4, 1, 2 minus 2 minus 3, which is a first row vector. Second row vector is 0, 16 minus 7 minus 6, 8, 19, 0, 0, 1, 2, 0 minus 5. So these 3 row vectors are basis for the row space of U as well as the row space of A. But if you want to find the column basis for the column space, what we have to do? The first column have a leading entry, second column have a leading entry, and the third column have a leading entry. So corresponding that 3 column vector in U, corresponding first 3 column vector of A, 2 minus 1, 10, 4 minus 4, 2 minus 4, and 1, 0 minus 2. So this 3 column vector form a basis for the column space of A. So here is the answer, R1, R2, R3 form a basis for the row space of A, and C1, C2, C3 form a basis for the column space of A. Next topic is rank and nullity, which is very easily you can find. Rank, the definition of rank is the common dimension of row space and the column space of a matrix is called the rank of A. So nothing but we have to convert the given matrix into a row echelon form, and whatever the number of non-zero row in the row echelon form, that is exactly the rank of a matrix. Okay, and null space of A, that means the dimension of null space of A is called nullity, which we already find. Okay, here's some important theorem, that dimension theorem. Rank of A plus nullity of A is equal to n, the number of column. Here is the matrix, find the rank and nullity of the matrix. 2, 0, minus 1, 4, 0, minus 2, 0, 0, 0. Here is the matrix, and we convert into a row echelon form with one simple process. We multiply first row with minus 2 and add into the second row. So the given matrix become in row echelon form. Only the one non-zero row, so the rank of A is 1. And what is nullity? How many columns? 3 columns. And we know that dimension theorem, rank plus nullity is equal to the number of column of the matrix. We already find the rank is 1 and the number of column is 3. So definitely nullity is 2, because 1 plus 2 is equal to 3. So nullity is 2. Okay. This is just a solution of the given matrix. Find rank and nullity of the next example. Find rank and nullity of the matrix. 1 minus 1 minus 1, 4 minus 3 minus 1, 3 minus 1, 3. Again we convert this matrix into a row echelon form. We multiply first row with minus 4 and add into the second row, and we multiply first row with minus 3 and add into the third row. In the next process, we multiply second row with minus 2 and add into the third row. So you can see on the screen there are only 2 non-zero rows. So rank of A is 2 and we have 3 columns. So definitely nullity of A is equal to 1. Okay, and you already know that how to solve the equations. Okay, so here I complete the vector space, the whole chapter vector space. So thank you.